Good afternoon. We're back at the hydraulic press, and today we'll find out how the bent elements of ships, which make up the vessel's frame, are made. Let's see how precise bending of a T-beam on the Gefest press turns blueprints into components for large ships.
The ship's framework consists of numerous bent profiles. The most distinctive one is the half-bulb profile.
Daria, so are we crushing potatoes again today?
No, this isn't a reference to Belarusian potatoes. And we're not making potato pancakes today. In shipbuilding, a bulb is a thickening at the end of a beam. This element significantly increases the strength characteristics of load-bearing structural elements. Today we are going to bend exactly this kind of beam.
Now those are some abs. Hey, Ilya.
Good afternoon, Andre.
Can you help us out? We need to bend the beam. It's not far from here.
Oh! Let's give it a try, but remember, strength isn't everything.
We need to bend this beam. It's not working. I tried. Sansanich, you be the counterweight.
Yeah, this is a tough one. Just Sansanich alone won't be enough.
Gentlemen, that looks very impressive, but let's use the hydraulic press. Sansanich, let's load the beam.
The operating principle of the press is very simple, but its highlight lies in its precision and power.
The machine allows for precise bending of the beam along a specified contour. You can pre-model the bending cycle and account for the spring back of the profile. The press has a horizontal frame with an open top. On one console is the bending hydraulic cylinder, and on the opposite side is the table with bending blocks. The blocks can move freely along the working surface of the table via a ball screw drive powered by a hydraulic motor. The accuracy of the block movement is monitored by the press controller using a linear encoder. The bending blocks are capable of self-aligning to the surface of the workpiece. This prevents the beam from being crumpled. A clamp is located in the center of the table with the bending blocks. Essentially, this is another press, a kind of hydraulic clamp for securing the workpiece during bending. The clamp moves along the axis of the bending hydraulic cylinder on rail guides. The position and movement of the clamp and the bending hydraulic cylinder are monitored by linear encoders. Transport rollers are installed on both sides of the press. They lift the workpiece above the clamp's grip and move it to the next position for bending.
By default, the press is built on the basis of a control system. Optionally, we can offer practically all available controllers, including those of domestic production. An important feature of our company's presses is the use of servo drives to control the pumps. Thanks to this, we can eliminate additional hydraulic shocks, and it also allows for speed adjustment over a very wide range. We also use proportional hydraulics. The linear displacement sensors, most often from bulbous, allow us to control the movement of the cylinders and monitor them at any given moment. Optionally, we can also offer integration of our equipment into a unified digital system. In the optional version, CAD/CAM support is available, including connection to the specialized shipbuilding software Ship Constructor.
Daria Leonidovna, please review the work.
It looks right, but let's double-check all the measurements. At shipyards, geometry checks are traditionally carried out using templates or keeping up with the times with a laser scanner.
Ilya, I've seen your press, but I've never seen anything like this.
Yeah, this isn't just about power. It's also about the system and precision.
Today we saw how to bend a bulb flat profile for shipbuilding, and that was cool.
Gidro press is power and precision.